Okay. Now it's recording. All right, so we're taking the sine of the arctan of negative 3x. Remind me, what is the tangent ratio? Y over x. And so I need to make this into a fraction. How do I make that into a fraction? Put it over 1. Okay, so because this is a negative 3x and we're looking at arctan, which quadrant do you think my angle will be in? Probably in 4. We don't use the third quadrant for any of the inverse trig, so it's either 2 or 1 or 4. But I'm going to draw this in 4. Okay. The y is negative 3x, so that's down here. The x is 1. I'm missing the r, so we're using Pythagorean theorem. Before I bother doing that, what am I looking for? The sine. What's the trig ratio for sine? Y over r. Can you give me a situation where I wouldn't even have to calculate the third sine?
If it was a cotangent.
If it was what?
Cotangent.
Yeah, if it was cotangent. If the problem was the cotangent of the arctangent, what would your answer be? Be negative 1 over 3x. You just flip it, right? So, hint, hint, wink, wink. Look out for that, because some of you are just going to happily calculate the third side and not use it at all. So don't waste your time. Make sure you actually need to find it. We do need to find it because of sine. So, Pythagorean theorem, x squared plus y squared equals r squared. That's 1 squared plus parentheses negative 3x squared equals r squared. So r is going to equal the square root of what? 1 plus 9x squared. And then subbing that in here, y over r is going to equal negative 3x over the square root of 1 plus 9x squared. Please don't rationalize it. Just don't rationalize it. Then it will just match my key. Okay, so there's a reason that we reviewed that, because we're going to take this idea of the right triangle and use it to help us with our derivatives of our inverse trig functions. These are the last set of derivative rules that we need to study. I will tell you that BC learns them at the beginning of the year when they do all the derivative rules. I like to wait till the end of the year to do these because they're very complicated and you've got a lot going on in your brain to remember all of those derivative rules, that this is just too much. So we're waiting until now and we're coming back and kind of doing the inverse trig functions all at the end. They are important because they allow us to integrate fractions that we otherwise can't do without the inverse trig functions. We're going to see that next week as we integrate these functions. So here is the title of your section. Please title this section 3.3, Derivatives of Inverse Trig Functions. Derivatives of inverse trig functions. And you don't have to write down the sentence, but we're going to talk about where these rules come from today. Derivatives of inverse trig functions. So down here at the bottom, I want you to look at these two equations. It says pi over 6 equals the inverse sine of 1/2. So can anyone explain to me why the inverse sine of 1/2 is pi over 6?
The sine of pi over 6 is 1/2.
Because the sine of pi over 6 is 1/2. Thank you, student. So these two equations are expressing the exact same relationship. It's just a different way of writing it, right? If y equals 2x, what does x equal? Y over 2. That's the same relationship, right? That's the same line. It's just different ways of expressing it. One of these is in terms of x, one of these is in terms of y. We had to do that with our area and volume problems, okay? So if I look at a problem like if I look at an equation like y equals the inverse sine of x, and I say, hey, what's the derivative of that? Nobody in here knows the derivative of the inverse trig functions. That's why you came to my class today, right? Yeah, because that's what's on the calendar. You're like, I really want to learn how to say inverse trig differentiation. I know that's what you're thinking. So we don't know that, but all of you are expected to know the derivatives of the regular trig functions. Right? What's another way to write this equation? I'm sorry, let me rephrase. If I solve this equation for x, what would x equal? It would equal the regular sine of y. Yes? If the sine of y is x, then the inverse sine of x is y. Yes, those two things mean the same thing. Now, we don't know how to take the derivative of that. Oh, but we do know how to take the derivative of this. What's the derivative of sine, regular sine? Everybody? Cosine. Okay, but the problem here is this is not the sine of x, this is the sine of y. What's the derivative of the sine of y with respect to x? Oh, there's that special type of differentiation we did in this situation. Oh, implicit. It's like I told you what we were going to use. Implicit, yeah. So implicit is where you use your chain rule, right? What's the derivative of the sine of y with respect to x? So first you're going to take the derivative of sine, which is cosine of your stuff, y, times the derivative of the inside, y prime. Yeah. So we're kind of tricking this by rewriting to calculate the derivatives, we rewrite each equation using a regular trig function and then use implicit to solve for y prime. Okay, we are going to derive two of them. We're not going to derive all six, we're going to derive two. Here's the first one. Okay, so let's let y equal the arc sine of u. U is going to equal some function of x, so please write that down. Our goal here is to find y prime. Now, the advantage of solving this with a u is now we can take the derivative, we'll be able to take the derivative of the arc sine of anything, of 2x, of x squared, of the square root of x, of 1 over x, of any, u is just any function of x, right? This, again, is a lot more useful to us than just taking the derivative of arc sine x, right? What if it's something else? Okay, so we're like building the chain rule into this. Now, we don't know the derivative of arc sine, but if we rewrite this, so essentially what you're doing is you're taking the sine of both sides, but what's going to happen on this side? When you take the sine of the arc sine of u, they're going to cancel each other out. So we are simply rewriting this inverse trig equation as a regular trig equation, and we're swapping the variables. That's how you find any inverse, right? So the sine of y equals u. So this is what we're going to differentiate. It says to find y prime. What does y prime mean? It means dy dx, right? So we're trying to take the derivative of y with respect to x. And in this case, since u is a function of x, you should have u's in your answer, right? Your answer should be in terms of x or in terms of u in this case. All right. So we are going to, kind of want a different color. We're going to take the derivative of both sides with respect to x. We're going to take the derivative of both sides with respect to x. And this is the part that's going to use implicit. So here, the derivative of the sine of y with respect to x, use your chain rule. So we said the derivative of sine is cosine of y times y prime. The derivative of the inside is dy dx, or y prime. Okay, that side's good. This side, what's the derivative of u with respect to x? Yeah, it's literally just du dx. What's another way to write du dx? U prime. So let's just keep it simple. U prime. Okay, we're almost there. What are we trying to find? Oh, there it is. How do I get it by itself? You can talk to me. You're not using names. You can talk to me. We're going to divide both sides by the cosine of y. Hey, we did it. No, we didn't. Since I'm finding dy dx, my answer should only be in terms of x, or in this case u, and you can't have any y's in your answer. Nope, we're not going to use the quotient rule, student.
You put arc sine u.
Well, the deal is I need to figure out what the cosine of y is. Okay? I need to figure out what the cosine of y is. But looking at this equation, I don't know what y is, but I know the sine of y is u. And if you know the sine of y is u, can't you figure out the cosine of y? Yes, you can. Smells like a right triangle. Let's draw one. All right, so let's assume that we are in quadrant 1. And this time y is the angle. Y is an angle. And I know that the sine of this angle is equal to u. How do I write sine as a trig ratio? Y over r. Those of you who prefer SOHCAHTOA, how would I write sine? Okay, so either way you want to think about it. Y over r, opposite over hypotenuse. But what is the sine? The sine of y is u. Oh, I heard someone say it. We got to write that as a fraction. U over 1. So u over 1 is the sine of this angle y. So let's draw a right triangle. Which side of the right triangle is u? Is it the base? Is it the altitude? Is it the hypotenuse? It's the altitude. There's your u, because that's the opposite from the angle. Where do I put the 1? That's the hypotenuse. Oh, look, I'm now missing this side right here. I'm not going to use an x because that's extra confusing since we're integrating or differentiating with respect to x. So I'm just going to put an a here for the adjacent side. You can really call it whatever, but okay, find a. Do the Pythagorean theorem and calculate a. A squared plus u squared equals 1 squared. A squared equals, we got to subtract. So 1 squared is 1. I'm subtracting the u squared over to this side. And how do I find a? Take the square root of 1 minus u squared. Cool. Now I know the missing side of my triangle. I'm trying to figure out the cosine of y. What is the cosine of y? Well, now I know all the sides of this triangle, so the cosine, what's the trig ratio for cosine? X over r, or you can think adjacent over hypotenuse, whichever one you want. So from this picture, what's the cosine of this angle y? It's going to be a, which is the square root of 1 minus u squared, over the hypotenuse, which is 1. There you go. Now look. Let me get a different color. Of course, you guys know anything divided by 1 is itself. So this is the cosine of y, and I'm going to plug it in right here. And now my entire derivative is in terms of u. Y prime equals u prime over the square root of 1 minus u squared. Congratulations. You took the derivative of arc sine. But miss, why didn't you just give us the formulas? Because if I just gave you the formulas, you'd be like, why are there fractions? Why are there square roots? Where does this formula come from? Here it comes from this. It comes from the sides of the right triangle. It comes from the regular trig functions and how all the trig functions are related to each other. Okay, questions on that? You don't have to redrive this. All you have to do is memorize them. I just want you to understand where they come from. Let's do this with one more. Let's find the derivative of arctan in the same process. Same process. I will just give you the rest of them, but let's do one more. Also, if you know where they come from, they're easier to memorize. Because you're like, oh yeah, they're all fractions. Because the trig ratios are all ratios. Okay, arctan of u. We're going to rewrite this as the tangent of y equals u. We're going to take the derivative of both sides with respect to x. We're going to use implicit differentiation to take the derivative of the tangent of y. Oh my. Do you guys remember the derivative of tangent? What happens when you get a tan? Let's decide as a class. Decide what's the derivative of tangent. You actually have flashcards. I love that.
Oh, good morning, Brett.
We don't use names in here.
What's his nickname?
Bad student.
I don't think I have it.
It's secant squared. It's secant squared. Sexy. Okay, so secant squared y times y prime equals the derivative of u with respect to x is u prime, or du dx. Solving for y prime gives me u prime over secant squared of y. So same thing, we're going to set up that right triangle. I know that the tangent of angle y is u. So let's draw that right triangle in the first quadrant. We're calling this angle right here y. But this time the tangent is u, or u over 1. Excuse me, what's the trig ratio for tangent? That's y over x. If you're thinking SOHCAHTOA, OA. So these may be now different sides of the right triangle because this is tangent. So opposite is your u, adjacent is your 1. We are missing the hypotenuse this time. So let's use the Pythagorean theorem to find that. 1 squared plus u squared equals r squared. What's r? It's just the square root of 1 plus u squared. Easy peasy lemon squeezy. I'm looking for secant squared of y. Before we square it, tell me what is the secant of y. Keeping in mind that secant is the reciprocal of cosine. So we're looking for r over x. Here's my r. This is the square root of 1 plus u squared. What's my x?
1.
So over 1. Okay, now we need to square it. So secant squared y would be this whole thing squared. Y'all tell me, what is the square root of 1 plus u squared squared?
1 plus u squared.
It's just 1 plus u squared. This is getting substituted in here. So now my y prime is written only in terms of u, and there are no y's in there. Cool. So y prime is going to equal u prime over 1 plus u squared. This is the derivative of arctangent. Okay, now again, you're not going to have to recreate this process. I'm showing you where they come from. Let's look at both of these side by side. Can anyone explain to me why this derivative has a square root in it and this derivative does not?
It's the derivative of tangent is the square root.
Yeah, right? The derivative of tangent is secant squared, has a square in it, so the square root gets canceled with the square, right? This one doesn't have a square in the derivative, so you should see a square root. What do these two derivatives have in common? On top of what? They're both fractions, and they both have u prime in the numerator, right? Because on both of those, I'm just taking the derivative of u. Okay, so they both have u prime. So it's just the denominators that are different here. Okay, I'm going to ask you to now, I want you to think if you were to do the same process with arcsecant. With arcsecant. You don't have to do it. I just want you to think about it. Would that have a square root in it? Would it only have a square root in the bottom? What do we think? What's the derivative of secant? Sextanx. There's two trig functions. There's the secant and the tangent, right? Now tangent, is the tangent going to have a square root in it? No, because tangent, well, maybe. It depends on which sides of the triangle you have. But one of those is going to have a square root and one of those is not. So here's what I want you to do. I would like you to copy down these rules exactly like they're written. I want you to copy these rules exactly like they're written. I have 2 columns and 3 rows, and I want you to copy it down exactly like this. And then I want you to start looking for patterns. So after you've copied this down, set your pencil down, start looking for similarities and differences, patterns, and ways that will help you memorize these 6 trig derivatives. You do need to have all of these memorized for Monday's quiz. All right, the way that these are formatted, you have arcsine, arctangent, arcsecant, and over here we have arccosine, arccotangent, and arccosecant. So what do these 3 functions have in common? We call those the co-functions. They all have co. Cosine, cotangent, cosecant. And what do you notice about all of these compared to these? They all have a negative u prime in the top. Now, all 6 of these derivatives are fractions, and what do they all have in common? They all have the u prime in the top. So that's the same for all of them. You just draw a fraction, stick a u prime in the top for every single one. Now I want you to look across. How are these 2 derivatives related to each other? The whole fraction is the same, except for the numerator is now negative, which means these are what? Opposites. These are opposites of each other. It's exactly the same fraction, but it's negative over here. Oh, look, that's the same for tan and cotan, and secant and cosecant. So really, if you memorize this column, you also have the other column memorized. You just need the negatives on that side, right? The cos have the negatives. All right, now I'm going to help you memorize these. Let's zoom in here. 2 of these have square roots. Which ones have square roots?
The one with the S in front.
Sine and secant. Oh, look, sine and secant have square roots. Tangent does not. Yeah, so the ones with the S, sine and secant, have square roots. That should be easy for you to remember. S has a square root. Okay? Which one has a plus in it? Oh, tangent is the only one with a plus. That T looks like a plus. There you go. That's the only one with a plus. Okay? You do have to remember, so one of these is 1 minus u squared, and the other one is u squared minus 1. The way that I personally remember it is like sine, that I kind of looks like a 1. And that's how I remember for sine, you start with the 1. And for secant, it's backward, okay? Now, what's the only one that has a second thing in the bottom? The secant has a second thing in the bottom that you have to remember, and you just have to memorize that is, please stop talking while I'm talking, thank you. You just have to memorize that's the absolute value of u in there, right? So we said the derivative of secant is sextinx. Here's one of the trig functions, here's the other trig functions, that's why you see 2, right? And here, it's secant squared, so the square root has gone away. That's why there's no square root there. So just little tricks to help you memorize those. You do need to have them memorized for your quiz on Monday. Now, for the quiz, I'm just going to show you. Before you get like the whole generic quiz, I'm going to give you a formula quiz. Here's what it looks like. I'm just going to say write down all 6 of these derivative rules for your inverse trig functions. Here you go. You're seeing the quiz right now. Oh, look. Here are the answers to the quiz. To the first part of the quiz. So these are probably getting worth like 2 points each. You're going to do this individually, just for me to see if you have your formulas. I'm going to collect that from you, and then I'm going to stick these up on the board so you can use them for the rest of the quiz. That way, if you don't have them memorized, you're not going to get a 0 on the quiz because you don't remember any of the derivative rules. So it's partially a formula memorization quiz, and then the rest is like, can you actually calculate the derivatives? Okay, so that's what's coming on Monday. Now, to work these problems, if you're trying to find the derivative of the arcsine of some function u, remember that u is a differentiable function of x. What you need for this formula, for this rule, is you need to know what's u prime, and what's u squared. If you have these three things, then you're just going to stick them in one of these 6 formulas, and that's it. So this is what I call my pre-work. Let's try a problem. Let's take the derivative of the arcsine of 2x. The derivative of the arcsine of 2x. Arcsine of 2x. Before we get started, what's the formula for the derivative of arcsine? U prime over square root 1 minus u squared. Look at you already starting to memorize those formulas. You're going to sleep 1, 2, 3, 4 times before your quiz, so make sure that you study over the weekend and you're ready for Monday. Okay, so in this equation, what is u? U equals, right here, that's your u, is 2x. So somewhere below or beside it, I'm going to do what's called my pre-work. If you do this ahead of time, then it makes the derivative super easy. So, what is the derivative of u? That's just 2. What is u squared? Well, 2x quantity squared would equal 4x squared. Once you've done this, you're just going to plug that in here, and that's it. That's it. So my answer is 2 over the square root of 1 minus 4x squared. Seems too easy. Well, that's it. We're starting off easy. Let's get comfortable with the basic idea of this before we make it overly complicated. Yes?
Is there like a quotient rule version? I appreciate it.
No, but your answer should be a quotient for all of these. Okay, now that we have already done the pre-work for u equaling 2x, oh look, these should now be super easy because both of these have a u of 2x. What would the derivative of our cosine of 2x equal? Oh, it's just the opposite of the arcsine of 2x. It's just negative 2 over the square root of 1 minus 4x squared. Boom, done. Hold on. So these are just opposites. What about the derivative of the arctan of 2x? So it's going to be positive u squared over, this one's the plus, 1 plus u squared. 1 plus. This one does not have a square root in it, and that's it. So once you've done the pre-work, it should be easy to find any of the 6 inverse trig derivatives from that point. Questions on that? All right, we've got a few more examples, but we'll save those for tomorrow. The examples shouldn't take all period tomorrow, which is great because then you can have some time to start working on your homework assignment. I am going to hand out the homework assignment today so that you have it.